This video is going to be on hyperkalemia, meaning that there's an increased potassium concentration in blood. The first cause for hyperkalemia is administration of potassium-containing fluids, and that's pretty self-explanatory, so I'm going to move on to the second and third causes, which are shifting of potassium within the body, or moving potassium around in the body, and decreased renal excretion of potassium. So first I'll talk about shifting and then moved on to decreased renal excretion. So shifting can occur with rhabdomyolysis, and you already learned about the changes that you'd expect to see with rhabdomyolysis. So to revisit those, you can see the hyponatremia lecture. But the other cause for shifting of potassium would be a metabolic acidosis. And this means that there's an increased concentration of hydrogen ions in blood. So to explain this, I am going to draw a blood vessel and a cell, and again, within the cell, that's called the intracellular fluid, or the ICF, and within the blood, that's called the extracellular fluid, or the ECF. And the blood and the cell contain lots of hydrogen and potassium ions. So with a metabolic acidosis, there are more hydrogen ions in blood, and the body attempts to neutralize the pH, so those hydrogen ions move into the cellular space, into that intracellular fluid. But the body also attempts to maintain electroneutrality, so potassium moves from the ICF to the ECF. So again, hydrogen ions move from the ECF to the ICF, potassium ions move from the ICF to the ECF. Now, when this occurs, this change tends to be mild, so usually it's within 1 unit of the upper reference limit, but occasionally it can get up to 1.5 to 2 units above the upper reference limit. Okay, so now for decreased renal excretion, there's 3 main causes for hyperkalemia there. The first of which is renal failure, and specifically anuric or oliguric renal failure, so the animal isn't producing any urine or is producing very little urine. And then also hypoadrenocorticism, which is also known as Addison's disease, and uroabdomen or a urinary tract obstruction. So unfortunately, the ClinPath changes that we see with these diseases tend to be similar. So there's decreased excretion of things that the kidneys excrete, so you'll have increased concentrations of serum BUN, creatinine, phosphorus, and potassium. And there's also decreased concentrations of the things that the kidney usually retains. So you'll see hyponatremia, hypochloremia. Although with a urinary tract obstruction, you tend not to get the hyponatremia and hypochloremia. It usually just occurs when there's actual leakage of urine into the abdominal cavity. Okay, so, well, maybe our urine-specific gravity will help. Well, it helps to some degree, but it's not the great distinguisher between these diseases. So with renal failure and hypoadrenocorticism, there can be inadequately concentrated urine for the species, and with uroabdomen or urinary tract obstruction, the urine-specific gravity can be variable. So we're going to have to look at other ClinPath changes which may or may not be present. So with renal failure, we'll look for protein loss in the urine, so a protein-losing nephropathy. So too much protein in the urine compared to, or what you expect for that urine-specific gravity. We'll also look for other signs of tubular injury, so there may be casts in the urine, or there could be glucoseuria without hyperglycemia, meaning that the tubules aren't resorbing the glucose that makes it into the ultrafiltrate. With hypoadrenocorticism, there is a deficiency of cortisol. So oftentimes these animals will present very ill. So they should be stressed, but you don't see evidence of stress in the leukogram. So meaning that you don't have a lymphopenia. So lymphocytes may be normal, or they might be increased in an animal that is obviously stressed. Other changes that may or may not be present, you might see hypoglycemia and or hypocholesterolemia, and that's because cortisol increases the energy in blood. So if there's a deficiency of cortisol, then there might be deficiency of energy in blood. So hypoglycemia, hypocholesterolemia. And then to diagnose your abdomen or urinary tract obstruction definitively, you really need physical exam findings. So with hyperkalemia, the three main causes are administration of potassium-containing fluids, shifting of potassium within the body, and decreased renal excretion.